Okay, in this question I decided to take a graphing, a speed time graphing, some data there, and show you just how to graph it. This is kind of funny looking data. It's not nice and even or anything like that, so it's a good example to work from. So the first thing is it gives us a speed in meters per second, and it gives us time in seconds. But if you notice how the numbers go up, well, the speeds start off nice and even, 10, 20. Then it goes down a small little bit, 29 at 3 seconds, 37. So you can say it's not exactly even. Another thing to watch out for is the time axis. So if you look at the times that you're giving, you're going 0, 1, 2, 3, 4, then it skips 5, goes to 6, and after that we start counting in 2. So it goes 6, 8, 10, 12, 14. Now, I think that a mistake that many people would do is they would lay out their axis exactly as it is here. Okay, a big mistake here is to just go 1, 2, 3, 4, 6, 8, 10, 12, 14 on the time axis, and then on the speed axis to just follow the numbers that you have. If you do that, you'll get a perfectly straight line, but it will be completely wrong. Okay, because that perfectly straight line will indicate that we've got a uniform acceleration when in fact it's not. So what I did was, because I tend to, when I do these types of problems, is I tend to prefer to look at them vertically. I just rewrote the data. You don't have to do this, but I did. From 0 to 14 and from 0 to 65 meters per second. Then I laid out my axis. Okay, now let me just show you how I did this. Okay, so the first thing I did was I set up my XY axis. I labeled it speed in meters per second versus time in seconds. Then I chose an increment of 5 meters per second because I knew my top speed was 65 meters per second. So I decided to go up in 5s, 5, 10, 15, 20, all the way up as far as 65 meters per second. On the time axis, I decided to just go across in 1s. Okay, so it's very important that you spend a few moments deciding what way to lay out your graph. Okay, very important that you do, and when you do it, it should go in even increments. Okay, you cannot go from, say, 5, 10, 20 and then go to 29, okay, because it just looks totally wrong and it will send you down the wrong path. Then I plotted out the points that I was given in my data, and notice the first few, let me just play it back, the first 3 points line up perfectly, and after that, at time equal to 3 seconds, you've got 29 meters per second. So it's just below that 30 meters per second line. And that kind of continues on as you go. Notice the gap there between 4 and 6, because after 4 seconds we start counting in 2s. So I continue on like that, continue on plotting on my data all the way to the top. I then kind of, when I laid out when I put in the line, I use a straight line for that lower part because I can tell it's perfectly straight. And then I freehanded most of the rest of it all the way up until the time equal to 13 seconds. Sorry, I think that's a mistake. It should be 12 seconds. Made a slight error there. Let me fix it. Okay, so I fixed my error. So I'm just going back a small little bit. I went all the way up to 14, plotted those few data points. The mistake I had made was between, it's just here, okay, and this data point should have been at 10, and I think I had it at 11 on the original. So that was at 10, and the value is 64 meters per second if you check the data. Then it was 65 for the following two, and then I just finished it off by joining up the line between from all the way from the start to the end. Okay, So that's the graph drawn. Now let's see if we can answer the questions that go with it. So I'll move back across and I'll zoom in so you can see them a bit better. So first thing is to plot a speed time graph, and this is fine. Then question B asks, what was the Ferrari's acceleration, because obviously it was a Ferrari, time equal to 13 seconds. 13 seconds. So again, if this is just graph reading, if you just come across to your graph and you find time equal to 13 seconds, and let me just highlight it. So 13 seconds is here, and if you come up along from there, then you'll see that at this point, during this interval, this entire interval between here and here, the speed doesn't change at all. Okay, it doesn't change at all. So the change in velocity is 0. And if the change in velocity is 0, that means the acceleration must also be 0. Okay? Because that part should be flat on a speed time graph. And of course, the slope of the speed time graph, gradient of the speed time graph, gives us the acceleration. The next thing is at time equal to 1 second, so I got to come back to the start of the graph. So at time equal to 1 second, well, now I'm here. Okay, I'm here, and again I'm getting the slope of the line at this point. So acceleration at time equal to 1 second would be the slope of the graph, which would be the rise divided by the run. Apologies if the video is blinking right now, that's what's happening for me. Well, it's constant. It's a constant acceleration between here and here, so it doesn't really make a difference where you take your points. I'm just going to go all the way out as far as 20. It doesn't make a difference. Okay, you can do it at 10 if you want as well. Well, I guess let's look at it here at this point then. Over this point, it has risen by a positive 10 meters per second over a time of 1 second. And that gives us 10 meters per second squared. But I just want to show you that it doesn't really make a difference where you take it, so long as it's on a straight line. So I could have just as easily said it was the rise all the way to 20 over a 2 second time frame. That would be a positive change in speed of 20 meters per second divided by a time of 2 seconds. And of course, that would give you the exact same thing. It would give you 10 meters per second. Okay? So long as it's a straight line, it doesn't really make a difference where you take it from. So just to come back over the side, there's a couple of practice questions here. There's one on graphing. You don't necessarily have to include this step here. Okay, you can just go straight ahead. But please be aware, okay? In this case, the time is on the top line and the velocity is on the bottom line. So please make sure that you go through this carefully and that you plot them carefully on your time and speed axis. Notice that the time goes up in 5 second increments all the way to 50, and the velocity seems to peak at about 15, seems to flatten off for about 20 seconds, and then drops back again. Okay, so that should form a nice curve, something like that. Okay, so give that one a go and make sure you put it in your